powerful and flexible. This is the fundamental unit of object-oriented programming. So let's take a working copy of class.cpp and we will paste it into our working project here. I'll go ahead and double click on that and open it in the editor, and we'll double click on the tab there to maximize this so you can see the entire thing. So here we have a very simple class definition beginning on line 6. You notice it has one data member, int I. It's a private data member because it's not specified otherwise, and members in classes in C++ default to private access. We have two public members, and you can see they're declared as public on line 8. And those public members are both function members, and they're called setters and getters. One gets the value of I and one sets the value of I. So you can see these are defined just as normal functions would be defined. Set value returns void, and it takes a value as an argument, an integer, and it assigns I to that integer. And I is the private member in the class. So this member function has access to the private members in the class. The next one returns an int get value, and it simply returns the value of I. So that's our very, very simple class. We can see it's used at line 15. An object is declared using that class. So this is called instantiation. That's an instance of that class. It's an object of that class. And at line 17, we actually call the member function setValue with the value of I from main, and I from main is 47. This is not the same as I from the class. The I from the class is not visible here at all because it's a private member. And so object1.setValue sub I, that calls the setValue method in the object1 object, which is of type class 1, and it passes it the value of I, which is that I equals 47 from line 14. And then cout calls object1.getValue to get the value, and it should print value is 47. So let's go ahead and compile this and run it, and you see it says value is 47. Normally, it's considered best practice to separate interface and implementation. What that means is that these functions here, these are actually implementation. The function signatures of them, that's considered interface. But the actual code, that's considered implementation. So typically how this is done is we would take these and move them down here and leave inside the class, we would leave just the function signature. And if we take off that actual function definition, then we need a semicolon here. So I'm going to do the same with getValue. And then we have two functions out here. Let's go ahead and format them like we would normal functions. Now you notice we have syntax errors here, because symbol I could not be resolved for both of these. And that's because the compiler does not yet know that these are actually implementations of methods that are defined in class 1. And we tell it that by giving the name of the class and 2 colons as if it were a namespace. The name of that class has a 1 on it, and there we go. So I'll take that and I'll copy that and I'll paste it down here. And now the compiler knows that these are implementations of function members, of methods that are defined as part of class 1. So up here from line 6 through 11, we have the interface, and that tells us how our class is used. And then in lines 13 all the way down to line 19, we have the implementation. This is the code that actually makes the class work. Now, normally all of this would be in really 3 separate files. I'll maximize this again, we can look at it. The class definition, the interface, would be in a header file, and it would be probably named class1.hpp. And the class implementation would be in a separate file called class1.cpp. And those would get compiled together and they would get linked with the code that actually calls it, and that would be in one or more other CPP files. But for our purposes, for our teaching purposes, as you're learning the basic syntax of C++ classes, we're going to be using really simple examples, and we're going to be putting them all in one file like this, just so that you can see how all this stuff works, and it makes it simpler for our purposes. Just know that normally these things would be in separate files. So let's go ahead and save this and run it, and you can see that it works just fine. and it works exactly as we expected. So sometimes we'll do it this way with the implementation separate from the class. Most of the time we'll do it that way, but it'll all be in one file. And occasionally, just for simplicity's sake, we'll go ahead and put the implementation, if it's really small, oftentimes we'll go ahead and put that inside the class definition. That usually happens for constructors and very, very small functions. So let's go ahead and delete